Welcome back, secondary educators. In this screencast, we take a look at one of the staples of high school mathematics. We're going to take a look at the quadratic formula. We're going to figure out why it is the way it is. This is the generic quadratic equation, ax squared plus bx plus c equals 0. And we're going to prove that the quadratic formula does what we say it does. So first we'll factor out the a, because it is easiest to complete the square if the coefficient on x squared is 1, and if a times something is 0 and a is not 0, we can divide that out. If a is 0, this isn't even a quadratic, so a is definitely not 0. And then we complete the square. Well, how do we complete the square? Well, we kick this number to the other side. And you're thinking, this doesn't look like the quadratic formula. It doesn't even look close to the quadratic formula. And then we're going to complete the square. Well, what does that mean? It means that we're going to add the number to both sides of this equation that completes this square, that makes this x plus something squared. Well, what's that something going to be? Well, that something is going to be half of this coefficient. And now it's sort of starting to try to take a look like quadratic formula type stuff. Well, what's the number that completes the square? Well, it's the square of this fraction here. It's the square of this fraction here. It's the square of this fraction here. So now we've got to combine these on a single denominator. We'll combine those on the denominator 4a squared. That's a b squared minus, and then to make this have the same denominator, we multiply by 4a over 4a. And now this very much looks like something we have seen before. And so we take the square root on both sides, taking the square root plus or minus on one of the sides. Don't need to take it on both of the sides. And then what? Well, we get x by itself by moving this to the other side. They have the same denominator, so we can put it all over 2a. We bring the plus b to the other side. There's a plus or minus, and by golly, this is the quadratic formula. This is the thing that teenagers for years have used to solve quadratic equations. We start with ax squared plus bx plus c equals 0. We end with this thing here. This is what teenagers remember coming out of high school. Now, I would be remiss if we didn't talk about one other thing. I would be remiss if we didn't talk about the discriminant. The discriminant is usually abbreviated with a capital delta because it makes the sound d, and it's b squared minus 4ac. And you may remember that there are 3 scenarios. If the discriminant is positive, if the discriminant is 0, and if the discriminant is negative. Well, if the discriminant is negative, if this number under a radical is negative, then you take the square root of that, you get an imaginary number, which means that this number is non-real and complex. There are 2 non-real roots. They can't be real because you can't take the square root of a negative number and get a real number. If the discriminant is 0, if this number underneath the radical is 0, then we're adding and subtracting 0. Well, that doesn't change this at all. You get negative b plus 0, you get negative b minus 0. There's one double real root. And then if the discriminant is positive, then we're adding a number and subtracting a number. We're adding and subtracting a positive number. And so we get 2 distinct roots. We get 2 distinct real roots. And this is the difference between quadratics that hit the x-axis twice, a quadratic that hits the x-axis once, and a quadratic that doesn't hit the x-axis at all. So every time we talk about the quadratic formula, we start with ax squared plus bx plus c equals 0. We use completing the square. This is why every high school curriculum teaches completing the square before it teaches the quadratic formula. It is precisely for this reason. And then every curriculum goes on to talk about the discriminant because it is a natural outflow of work with the quadratic formula. All right. We're going to talk about roots and factors in the other screencast coming up right after this.